this problem for motion of projectile. Okay, and the problem is the angular elevation of an enemy's position on a hill h meter high is beta. Okay, so the enemy's position of angular elevation is beta at height h, okay, on the hill. So that in order to sail it, that is, we want to hit the enemy, the initial velocity of projectile must not be less than this. We have to find the initial velocity, that is, we normally take initial velocity is u and angle of projection is alpha, and we have to show that u must not less than this to hit the enemy. Okay, now we take the point of projection is O. This is origin, this is x-axis and this is y-axis. Let the position of the enemy is this is P, and at height h it is given because h meter high, and the angular elevation, this means the angle, this angle is beta, right? And if we take this is M and OM is A, then the point P is given by A comma H. This is the coordinate of P or enemy's position. Now we project the particle from here with initial angle alpha. With initial angle alpha and initial velocity of projection is u, this is alpha. Okay, so we know that this velocity or velocity along x-axis is u cos alpha, and the velocity along y-axis is u sin alpha. Okay, now we know that in that case the path of the projectile is given by, we already write here the equation of the path of the projectile with angle of projection is alpha, and at any point P which is x, y, this is given by this. And at any point, if we take this point, this is the general point, the velocity is at here, this is v, and here the force only, this is mg, downwards direction, and no force along x-axis, that is x double dot, this is equal to 0, and the equation of motion are x double dot equal to 0 and y double dot, this is equal to minus. If we solve this equation of motion and eliminate t from both the equation, we get this path. Okay, and we apply the initial condition as 0 0 at t equal to 0, and initial velocity along x-axis is u cos alpha and initial velocity along y-axis is u sin alpha. Okay, now we have to find the initial velocity. Now we have to find the initial velocity, or we have to show that the initial velocity of projection must not less than this. Okay, how to find this result? From the path of the particle, we know that this is y, this is equal to x into tan alpha minus g x square by 2u square into sec square alpha, because 1 minus cos square alpha, this is sec square alpha, and we put sec square alpha is 1 plus tan square alpha. So we put here 1 plus tan square alpha. Now we get g x square by 2u square into tan square alpha minus x into tan alpha, because all the term we get in the left side. plus y plus g x square by 2u square. This is equal to 0. Now this path of the projectile passes through the point P. So it must be passes through the point A, H. That is, we put here x equal to A and y equal to H. And we get the relation as g into a square by 2u square into tan square alpha minus this is a tan alpha plus this is y, this means h plus g a square by 2u square. This is equal to 0. Now this is a quadratic equation of tan square alpha. So if the projectile really passes to the point P, so we get here 2 real value of tan alpha or 2 real value of alpha, because this is quadratic equation of tan alpha. And for real value of tan alpha, we must have the discriminant greater or equal to 0. So we get discriminant D this is equal to b square minus 4ac, which is b square minus a whole square minus 4 into a means g square by 2u square into c means h plus g square by 2u square. Evaluating this discriminant as simple as possible, we get a square minus, we cancel out 2 to 4 with 4 and get g square by u to the power 4 into 8u square plus g square. Okay, greater equal to 0. Now we take common a square and cancel out for both sides. We get u to the power 4 minus g into 8u square, here 2, if we add and take LCM 2, then here must be a 2. So this is 2 plus g square greater equal to 0. And this relation gives u square whole square minus 2 into u square. This is u square and this is gh plus gh whole square minus gh whole square, and the last term is minus g square greater equal to 0. So we get u square minus gh whole square greater equal to taking common g square, we get h square plus a square, and this relation gives u square minus gh greater equal to g into root over of h square plus a square. So this is u square greater equal to gh, or taking common g, h plus root under h square plus a square. Okay, and for the real value of tan alpha or real value of alpha, we must get u square greater equal to this value. Now we have to prove that the velocity of projection, this is not less than this value. Okay, now here we put the value of this term. Here this is a and this is h, this is height, this is base. Okay, and this is must be root under h square plus a square. This is hypotenuse. Okay, now if we take common h from this relation, we get this is u square greater equal to gh into 1 plus root under this is h square plus a square by h, and this relation gives root under h square plus a square by h, means this is hypotenuse and this is height, and hypotenuse by height, this is cosec beta. Okay, for this angle, this is the angle beta, and this is the triangle OPM. Now we get U. This is given by greater or equal to GH into 1 plus cosec beta whole to the power half. So the initial velocity of projection is greater or equal to GH into 1 plus cosec beta whole to the power half. So we have proved that the initial velocity of projection must not less than GH into 1 plus cosec beta whole to the power half. Okay, this is very important problem of projectile.